So let's go ahead and prove the double angle for sine. Okay, so if the sine of a double angle the claim is that the sine of 2x equals 2 sine x cosine x. Okay, and while we're at it, I think we're going to go ahead and also prove this claim, that the cosine of 2x is equal to, and there are usually a few variants of this, but the one that I find to be the most convenient is cosine squared x minus sine squared x, I suppose, because this is a difference of perfect squares. So I'm setting up this circle here to accompany my proof. Okay. Now, I think what I'm going to do is use the geometric property, okay, that inscribed angles and central angles that subtend the same arc are in a 1:2 ratio. So, in other words, if this is alpha here, this would be 2 alpha. Okay. So this is, without loss of generality, what we know to be the case. So I'll use this diagram and this property to assist in proving this. Now, let's consider for a second that it is radius r. Okay. Now, all circles are similar to all circles, so it really doesn't matter if it's radius r or radius anything for that matter. But let's just go ahead and set this up and define these as we know we can define them. This is going to be r times the cosine of 2 alpha. Okay, this right here, of course, r times sine of 2 alpha. Okay. Now, these individually, okay, they're both congruent, by the way, and they both equal to r times the cosine of alpha, each of them. Okay, so this whole side therefore is going to be equal to 2r cosine alpha. Okay, so let's just use the Pythagorean theorem. R cosine of 2 alpha plus r. Okay, so this squared plus r sine 2 alpha squared. Okay, should equal 2r cosine alpha all squared. Okay. Okay. Well, yeah. As you can see, you can divide everything through by r squared. Okay. We'll do that in the next step. So let's go ahead and expand. We're going to have r squared cosine squared double alpha. Okay. Plus r squared. Plus, it's going to be 2. Now it's r times r, so it's 2r squared cosine 2 alpha. This here gives us r squared sine squared 2 alpha. And over here, of course, we get 4r squared cosine squared alpha. Okay, so dividing everything through by r squared. Okay, so we're going to have cosine of 2 alpha, okay, plus 1, plus 2 cosine 2 alpha, plus sine squared 2 alpha equals 4 cosine squared alpha. Okay, so cosine squared alpha cosine squared 2 alpha plus sine squared 2 alpha is just going to be 1. So This becomes 1, which is, when added to 1, 2. So it becomes 2 plus 2 cosine 2 alpha equals 4 cosine squared alpha. Okay, let's divide everything through by 2. Okay, let's now go ahead and subtract 1. And we don't have this, I guess, in the exact form we wanted to have it in, but we can get it in that form if we realize that 1 is simply going to be cosine squared alpha plus sine squared alpha. Let's go ahead and put that in there. Okay, now we see how that certainly simplifies to what we were hoping it would simplify to, cosine squared alpha minus sine squared alpha. Okay, well, there's a first proof. I'll guess put a check mark by that second one. We still need to prove the sine of a double angle formula. That shouldn't be too hard. I think what I'm going to do is just continue on with where I was at, essentially right here. So I'm just going to kind of bring my work up here. Cosine of double alpha equals 2 cosine squared alpha minus 1. Okay. Why don't we go ahead and square both sides? I don't think we're going to get a quartic, but it won't be. I don't think it'll be too bad. No, actually it won't, because we can factor, and then yeah, it actually is going to work out just fine. Sometimes you want to think a few steps ahead here, but anyway, let's square both sides. So cosine squared double alpha, 2 cosine squared alpha minus 1, all squared. Okay, left-hand side, notice we can write it as 1 minus sine squared 2 alpha. Okay, using Pythagorean identity, sine squared theta plus cosine squared theta is equal to 1. Now this now becomes 4 cosine 4 alpha plus 1 minus 4 cosine squared alpha. Okay, let's just quickly check all of that. Yeah, that looks good. Now this is what we're trying to solve for. Clearly we can subtract a 1 from both sides, and I'll go ahead and divide both sides by negative 1. Okay, dividing both sides by negative 1, I can just write this as 4 cosine squared alpha minus 4 cosine to the 4th alpha. And that's the same thing as 4 cosine squared alpha times, yeah, this is working out really nice, 1 minus cosine squared alpha. That's the same thing as 4 cosine squared alpha times sine squared alpha, isn't it? Okay, and now to isolate sine of double alpha, we just need to take the square root of both sides. And clearly we're talking about positive angles. Okay, here clearly we're dealing with positive 2 cosine alpha sine alpha. Well, fun. You guys, I love doing proofs, and any puzzles, mathematical, physics, or otherwise that you might want me to take a look at, I post these just for fun, and because I want to share what I know, and I also am hoping to meet like-minded individuals who are as enthralled by mathematics as I am. I am working on original mathematics, complex analysis, and at some point, once I develop this channel enough, you'll see some of that. All right, have a great rest of your evening, and we will hopefully see you soon.